learners. Today we will see what is this Gauss law, right? So Gauss law talks about the flux, right? So as already we know how we have defined this flux and flux density, and the relation also we have seen. So let me write the relation once here between flux and flux density. We know that psi is equal to circle integral S we know that psi is equal to surface integral S d dot ds, where d is my flux density and psi is my electric flux. Now Gauss law states that if I take any volume, right, so the total charge, here I have q1, q2, q3 and so on. Let us assume I have n number of charges here. The total charge enclosed in this particular volume will be equal to the flux coming out of that particular surface, right? Let us assume this is what my volume, and I have q1, q2, q3 and so on, qn, n number of charges I am taking. So charge enclosed in this volume represented with, we know that if I am taking a volume charge, it will be represented with a charge density which is rho v. Psi is equal to q enclosed. Psi is nothing but my flux. The total flux in a surface will be equal to charge enclosed in that particular volume. So this is how we will define the Gauss law. Gauss law statement talks about the flux and charge in a particular surface as well as volume. Already we have a relationship here. Psi is equal to integral S d dot ds, which is nothing but the relation between flux as well as flux density. And already we have one more relation also, that is nothing but, as I am talking about a charge which is enclosed in a volume, which is nothing but my volume charge density represented with rho v. Now how to represent this rho v in terms of q? We already know that q is equal to volume integral v rho v dv, right? So this is what I have. Q is equal to volume integral v rho v dv, where rho v is nothing but my volume charge density. I can write q is equal to volume integral v rho v dv. Let me write all these equations together. So what are the primary equations we have? The first equation of Gauss law is psi is equal to q enclosed. This is I am taking as equation number 1. And psi is equal to integral S d dot ds. This is my equation 2. And already we know that from the volume charge density, q is equal to volume integral v rho v dv. Now let us take equation 3. If you observe here, psi is equal to q enclosed, nothing but all these 1, 2, 3 are equal. I can write 1 equal to 2 equal to 3, right? So when I take 1 equal to 2 equal to 3, now psi is equal to q enclosed is equal to integral s d dot ds equal to volume integral v rho v dv. Now see here, if you observe here the integration part, here the flux density will be represented in terms of a surface integral, whereas this volume charge density was represented, this charge density was represented in terms of integral v. Nothing but the surface integral here I have a surface integral, now here I have a volume integral. Now I need to convert this surface integral into volume integral so that I can able to make these parameters equal. Now see here, psi will be represented as, because it is a closed surface, that's why I am represented circle integral S d dot ds. Now again here I am writing q enclosed is equal to circle integral S d dot ds, right? Psi is equal to circle integral S d dot ds. Similarly, psi is equal to q enclosed, that is equal to circle integral S d dot ds is equal to volume integral v rho v dv. Now I am converting this surface integral into volume integral. To convert this surface integral into volume integral, I will be using divergence theorem. Now what is this divergence theorem talks about? The divergence theorem talks about it will be converting a closed surface integral into open volume integral. So here I have surface integral, circle integral s d dot ds will be equal to volume integral v rho v dv. So I can write circle integral s d dot ds is equal to volume integral v rho v dv. Now I am converting this. This can be done. Divergence can be done with a del operator. Divergence will be represented with a del operator. Now this closed surface will be converted into open volume. So now it is volume integral d dot ds, surface integration I have. So it will be represented as del dot d dv. Now see here, the surface integration, closed surface integral was converted into open volume integral. So d dot ds will be replaced with del dot d dv. This will be is equal to volume integral rho v dv. Now compare both right hand side as well as left hand side. I can write del dot d is equal to rho v. Del dot d is equal to rho v, which is my first Maxwell's equation. My first Maxwell's equation. So this is the first Maxwell equation.
Thank you for watching this video. Have a purposeful learning experience. Thank you.